Hello everyone. So today we are going to solve the sample paper of mathematics of unit test for class 11. Okay. Uh, Let me just tell you the chapters that are covered in this sample paper are the first two chapters. That is, the first chapter is sets and the second chapter is relations and functions. Okay. So let's just start. Now see the first question. What does the first question says to us? The first question says that there is a set A which contains two elements, that is in the first element that is curly braces 5 and the second element is the 0 comma 2. Some of you may say that there are three elements but there are two elements only. These curly braces represent one element and these curly braces represent the other element. That is, there are only two elements. Now we have to find the power set of A. Now power set of A is defined as the set of the subsets of set A. What I said just now, set of the subsets of the set A is called as the power set of A. Power set of A. Power set of A. Now see how can we write the power set of A. The first one is 5 because we know that empty set is the is a subset of every set, and the next subset will be curly braces 5. These two are different, and the third one will be 0 comma 2, and the next one will be the whole set itself, as we know that every set is a subset of itself. So here is 5 and then 0 comma curly braces 0 comma 2. So this is the answer of our first question. I hope everyone knows how to solve this kind of question. Okay, now the next question is convert the following set into a set builder form. We are given a series, and what is the series? A equals to 1, 11, 35, 79, and so on. 35, 79, and then dot 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 dot. All right. So we have to convert this set which is given in the roster form into the set builder form. That means we have to write what kind of series this pattern is, what kind of sequence, or we can say what kind of expression the series that is given to us in the set A is following. So let's just take an example like the first series that I think n square minus 3n plus 1. This you have to think from your mind only that what kind of series will this sequence follow. Now I have just taken a simple example that n square minus 3n plus 1. We have to check whether it follows or not. If it does not follow, then it is not the set. It is not going to be in the set builder form of the given set. So we have to look for another series that will, um, you know, follow this sequence. Now n square minus 3n plus 1. If n starts from 0, if n starts from 0, what will be the answer of this? This will be 1 because whole these things will be 0. Okay. Now next, if n equals to 1, for n equals to 1, this expression will give me negative value that is not required if n equals to 2. Now if n equals to 2, here will be 4 and 6, then also it will give me negative value. 6 plus 1, it will give me the negative value, that is minus 1. That is not required if n equals to 3. If n equals to 3, then it will be 9 here and Here also it will be 9 plus 1. That will give me 1. Now if n equals to 4, if n equals to 4, 4 square is 16 and it will be 12 and plus 1. Now that also does not give me the answer. That means the example that we took here. I hope you all got an idea of that how can we solve the question number 2 or the similar problems like question number 2. Now we will move forward to our next question, that is the question number 3. And in question number 3 we are given two sets. The first set is A, which is 5 and is the empty set. And the next set is B, which is curly braces 5. Curly braces 5. Now curly braces 5 is not the empty set, it is a singleton set, that is it contains only one element, that is 5. Now the question says we have to find the number of relations from A to B. Now the formula for number of relations from A to B is 2 raised to power 2 raised to the power m multiplied by n. And what are m and n here? M and n here represents the number of elements in the set A and n represents the number of elements in the set B. Now if we will write the number of elements in set A here, number of elements in set A will be 0 because it's an empty set and an empty set does not contain any kind of element, so it will be 0. Now the number of elements in set B. Number of elements in set B we have only one element, that is 5. So the number of elements in set B is 1. Most of the students might write here the answer without even thinking 0, but that's not correct because here we are talking about the number of relations. And if we will go by the formula, here will be 2 raised to power 0 multiplied by 1. And that will simply give us 2 to the power 0, which is equal to 1, which shows that this question number 3 and the sets given in the question number 3, these form only one relation from the set A to the set B. Okay, now let's move forward to the next question. That is the question number 4. We have to find the range of the fx. Function is given, we have to find its range. Fx equals to 3x square minus x plus 1. 3x square minus x minus 1. Okay, now this question is asked in only 1 mark question. So I'm going to solve it using the box method, or you can say the principal range method. Now see here, I will write here first the range of the x square. We know that x square lies between 0 to infinity because the square of any number is always positive and it can be equal to 0 and is always positive. So if I multiply this whole box with 3, then also I will have the same thing, 0 to infinity. Okay, this is a set of all positive real numbers. And if we will see here, we are given x, but in the question we are not given any kind of domain of x. So in the questions in which you are not given any domain of the x, you have to take the domain as all real numbers. That is, x belongs to the set of all real numbers. That is, I have to subtract minus r. Now see here, if I will subtract all the positive numbers from all the real numbers, then what will I will be left with? I'll be left with only the set of negative real numbers. The set of all negative real numbers, and in which 0 is not included because 0 is also a part. 0 is included here, so 0 will not be included here. Now I have to subtract 1 from this. Now if I'll subtract 1 from negative infinity, no change will be there. But when I subtract 1 from 0, then I'll be having minus 1. So this is the range of the question number 4 and this is the answer. I hope everyone understood what kind of question it was and what it wanted us to find. Now, next question, the section B we are going to start now. In section B, see, let me just move it here. Mm, hmm. Section B starts with the question number 5, and in question number 5 we are given two sets, and in the first part we are asked to find A minus B, that is the difference of the sets. And I will simply write here A minus B. But in the exam, you have to write first what is the set A, what is the set B, then you will write A minus B, the A part of the question. Now A minus B, I have to write those elements in this set which are in A but not in B. Okay. So let's just see for the first element, that is 3. 3 is only in A, I will write 3 here. Then 6, 6 is only in A, then I will write 6 here. Then the next element is 9. 9 is in both A and B, so I will not write here 9. And then 12. 12 is only in the set A. I will write here 9 here. I will write here 9. And then the next element, that is 15. 15 is in both. I will not write 15. Then 18. 18 is only in A. I will write here 18. And then the last element, that is 21, is also in A. So 21 is also written. So this is the answer of the first part, that is A minus B. The difference of sets is this. Now moving towards the B part. In the B part, we are asked to find A union B. That is, we have to make the union. So A union B will be all the elements in the set A and B, but without repetition. 3, 6, 9, 12, then 15, then 16, then 18, after that 20, and then finally the last element, that is the 21. Okay, so this is A union B. This is A union B. Okay. Now moving towards the next question, we are given a statement that is for any sets A and B, P of A, that is the power set of A union power set of B, is always equal to power set of A union B. This we have to check whether the given statement is correct or not, and then we have to justify our answer why it is not correct. So for this question, I would uh, like to take two examples of the sets. That is a set A, which will be a singleton set which will contain only one element. That is one, and then one more set, that is the set B, which will contain two elements, 2 and 3. 2 and 3. Okay. Now see here, you know that what is the number of elements in the power set of A? What is the formula of that? Number of elements in the power set of A. Number of elements in the power set of A is given by the formula of 2 raised to power n, that is where n represents the number of elements in the particular set or in the given set. Now in the set A, we have only one element, so I will write here 2 raised to power 1, that is 2. So in the power set of A, I will be only having two elements. And what are those two elements? I will write here power set of A. Power set of A will contain only two elements. The first one will be phi, empty set. It is a subset of every set. And then the set itself. Every set is a subset of itself. Okay, so this will be the power set of A. Similarly, the number of elements in power set of B. Number of elements in power set of B. It will be 2 to the power 2. Because the set B contains two elements, so it will the number of elements in the power set will be 2 raised to power 2, which will be 4. And what are those elements? Those are P of B, power set of B. Power set of B will contain all the elements. And what are those elements? Those elements are the subset of the B. The first one will be 5. The next one will be 2. The next one will be 3. And then the last one will be the set itself. That is 2 comma 3. 2 comma 3. I will not make this question too big because it's only a 2 mark question, and we have to write just here whether it is true or not and then justify. Okay, so if I will make the union of these power set of A union power set of B, power set of B. Rather than doing its union, I will simply ask you what are the number of elements in these power sets, union of these power sets of A and power sets of B. See here, 5 is in both, so 5 will be counted only once, and then 1 is only here and here. Okay, so it will be 1, 2, 3, 4, and 5. So number of elements in power set of A union power set of B will be 5, and then uh, A union B, A union B, A union B. What are the number of elements in A union B? Number of elements in A union B will be, see, A contains only one, B contains two. So number of elements in A union B will be three. And then power set of A union B. Power set of A union B. Rather than writing power set of A union B, we will write here, just check here the number of elements in power set of A union B, because you all know how to write the power set. So power set of A union B will be 2 raised to power 3 number of elements we are talking about. So it will be 8. Now look at here. Number of elements in power set of A union B is 8. But number of elements in power set of A union power set of B is 5. Both are different. So that means the statement given is false. No, the given statement is not true. The given statement is not true because we can write here the number of elements in power set of A union power set of B equals to 5, which is not equal to the number of elements in power set of A union B. Number of elements in power set of A union B. Okay. Now we will move forward towards the next question. That is the question number 7. Okay, we will move forward to the question number 7. Let me just fix it. Yeah, now it's fine. Okay, so we have to write here that now we have to solve the question number 7. Let me just erase the 6 here. I don't know why is it here. The 6 get erased. Okay, so the question number 7 says there is a relation given on the same set, that is z cross z, and the relation is defined as f equals to, the elements are in order where the first element is AB, and then the next element is A plus B. A plus B. Okay, and A comma B belongs to the set Z, which we can take as the set of integers. A comma B belongs to Z, and we have to check whether this given relation is a function or not. And for a relation to be a function, we know the x must be having only one y. But here you have to see, let's just take it as x1, then take it as x2. X1 and x2 can take. Now look at here how to define a set, how to define a relation as a function. Now see, x1 will give me the value y, x2 will also give me, let's just take an example. If x1 gives me the value as y, x2 gives me the value as y, and this condition is suitable for a function. But what if x1 and x2, y1 and y2? What does it mean? Uh, if y1 has the preimage as x1 and y2 also has the preimage as x1, so this condition will not be taken as, is not suitable for a relation to be defined as a function. That is, in this condition the given relation will not be a function. But if this is the condition, the first one, then the given relation will be a function. Or let's just take an example. We have to check whether the given relation is a function or not. So we have to take the values of a and b. Now let's just take a as 3 and b as mm, let it be 6. Okay. Now the first element will be ab. That is a product of both the numbers that we took. Both are integers. 3 multiplied by 6 will be 18. And then a plus b, if we will do a plus b, it will be 9. Now let's again taking a as 9 and b as 2. In this case, the first element, that is ab, will be equal to 18 again, and then a plus b, that is the second element, a plus b will be equal to 9 plus 2, that is 11. Now let's just make it more simple. Let's just say 18 is written here. 18 is written here, and here it is the value of x, and then here are the values of y. The first value of y is 9, the next value of y is 11. Now see here, if we will find the pre-image of 9, that will be 18, and if we have to find the pre-image of 11, that will be 18. And this condition is suitable for a function, for a relation to be defined as a function. Now we will write here yes. So this is the relation. This relation is a function. The relation, the given relation, the given relation is a function. Is a function. I hope you understood this question, how to solve this. All right. So the next question, that is the question number 8. And in question number 8, we have to find the domain and range. We have to find the domain and range of the function. All right. So let's just start with the question. That is the question number 8. See, if we have to find the domain, then for the domain to be defined, that is the set of all values of x, we have to make sure that the denominator does not become equal to 0, because if the denominator becomes equal to 0, if the denominator becomes 0, then this will not be defined, because something upon 0 is not defined. Okay. So for domain, I will write here the first condition, that is x square minus 8x plus 12. That this is the denominator of the given question. In the question, x square minus 8x plus 12 must not be equal to 0. All right. And if I factorize it, then it will be x square minus minus 6x and minus 2x plus 12 will not be equal to 0. Okay. Taking common, we will be getting two factors, that is first is x minus 6 and the next is x minus 2, which will not be equal to 0. From here we got two values, that is x will never be equal to 2 comma 6. That is, I can write from here, I got the idea what will be the domain. Domain will be set of all real numbers, but which two elements are not included? 2 and 6 are not included in this. Okay. Now the next part of this one, this question, that is we have to find the range. Okay. Let's just erase it. Now we have to find the range. How do we find the range of the question like this? X square minus, sorry, plus 2x plus 1, x square plus 2x plus 1 upon x square minus 8x plus 12. Okay, let's just take it as y. Now cross multiply this whole expression with y here, and then bring all these things here, and then take everything common which could be taken. Let's just write it here. I'm writing it directly, yx square, and if I will transpose this whole expression here, it will be negative x square, negative x square, and then minus 8xy. Here will be negative 2x. This will be plus 12y, plus 12y, and it will be here minus 1. This whole expression will be equal to 0. Okay, now let's just take common x square. Here will be y minus 1. Then negative 2x could be taken common from here. Mm, Here will be 4y, and here minus 1 or plus 1, plus 1. Then plus 12y, the same as it is, 12y minus 1 equal to 0. Okay, now we have to use our quadratic formula here. That is, but rather than the quadratic formula, we have to make sure that discriminant b square minus 4ac, it must be greater than and equal to 0, because this is the only condition when the quadratic equation is valid or have real roots. And for this quadratic equation to be having real roots, we have to apply this condition here. B square minus 4ac must be greater than and or equal to 0. We will simply write the values here, and the value of b is negative of 2, 4y plus 1, 4y plus 1. We have to make the square of this, and then negative of 4a. What is a here? A is here y minus 1, and c here is 12y minus 1. 12y minus 1. We are finding the range here. Okay, this whole expression must be greater than or equal to 0. Now see here what will be going to happen in the next few moments. We are going to solve this question. Let's just speed it up. This will be 4, and if we will open the square of this will be 16y square plus 8y. This will be plus 1 only, and here the bracket will be closed. Then negative 4. Here it will be 12y square and minus 13y, then plus 1. I hope I multiplied correctly. Let's just take here y and y. 12y square, okay. Then negative y, and then negative 12y, negative 13y, and then negative 1 plus 1. This whole expression greater than or equal to 0. Next, multiplying this 4 inside, this will be 64 y square plus 32y, then plus 4, then negative 48 y square, then positive 52y, then negative 4. greater than equal to 0. Okay. Now 64 minus 48. What will be the answer? 5, 14, 16. 16 y square, 32 and 52 added will give 84. If I'm not wrong. 84y. Then plus 4 and minus 4 will be cancelled. Okay. Will be greater than and equal to 0. Can we take 16 common from 16 here as common? 16, oh, 16, 5, 80. No, no, we cannot take. So what will be here? We can take 4 common from here. 4. Here will be 4y square plus 21y. Okay, it will be greater than and equal to 0. So here will be y could also be taken as common. If we will shift this 4 to the other side, it will become 0. We will be left with 4y square, 4y square plus 21y greater than equal to 0. Okay, which will which we can write as 4y square greater than equal to negative of uh, negative of 21y, negative of 21y. This square and this y cancelled. We got y greater than equal to, we got y greater than equal to negative 21 upon 4. Okay, or we can write the range, that is y belongs to closed interval negative 21 by 4 up to infinity. So this is the range of this question. I hope you understood the question number 8. Now let's just move forward towards the question number 9. All right, question number 9, and here the section C starts. Question number 9, we are given Phillips. Okay. U complement intersection A. U complement. U is the universal set. And what will be the complement of universal set? It will be 5. And they are asking us to find the intersection of phi and A. Phi and A, nothing in common. So the answer for first part is phi. Then in question number, same question, but the next part, that is a B part, phi complement intersection A. That is phi complement will be U, and then U intersection A. It will simply give me A. Then C, U minus A. U minus A. That is all the elements in uh, universal set, but not in the set A. That is A complement. I hope you understood the question number 9. All right, the next question, that is the question number 10, is an example from your NCRT. So you have to do it yourself. And if you find any kind of problem, you can comment down. And in the next video, I'll solve it. Okay. Now the next question, that is the question number 11. Fx, the function is given as 3 upon 2 minus x square. 2 minus x square. Okay. So we have to find the domain and range of this function. See, what will be the domain? Domain is a set of all set of all the values of x for which the function is defined. And here for the function to be defined, we have to make sure that the denominator does not become 0. That is 2 minus x square will never be equal to 0. Okay, 2 minus x square should not be equal to 0 ever. So here we will write x square must not be equal to 2. That will give me two values. That is, x must not be equal to negative of root 2 and root 2. That is, what will be the domain here? I will write here domain of the function equals to set of all real numbers except negative root 2 and 1 root 2, positive root 2. Except these two values, this function is defined. Then the range, I am applying here the box method. See here, x square. What is the range of x square? X square lies between 0 to infinity. And then we have to find 2 minus x square. That is 2 minus, this is 2, 0 to infinity, which will be 2 to infinity, closed interval, 2 to infinity. But we have to make its reciprocal because it's in the denominator. So its reciprocal will be simply 1 by 2 and 1 by infinity. 1 by infinity to 1 by 2. Okay, here was the open interval, here is the closed interval, and 1 upon infinity is 0, and here 1 by 2. And then we have to multiply this whole expression by 3. So it will be 0, comma 3 upon 2. 3 upon 2 closed interval. So this is the range and this is the answer for this question. Okay. Now moving towards the next question, 12th question is very simple. You have to do it yourself. Now the section D. See here, section D. First question of section D is question number 13. They are saying that we have to draw the graph of the function. See, this is our Cartesian plane. This is the Cartesian plane. All right. And okay, when fx equal to 1, if x equal to 0, fx equals to 1 when x equals to 0. So x equal to 0 will be here, and fx, that is the value of y, 1 will be here. That is the function lies like this. So this is the graph of this function. This is an example, miscellaneous example number 1 of your NCERT book, if I'm not wrong. Yeah, you must check it. Now the question number 14. Question number 14 is also very simple, and a question for of your miscellaneous exercise, then stated to De Morgan's law. I hope you all know what is the De Morgan's law. De Morgan's law states that if we will A union B, like A union B complement is will be equal to A complement intersection B complement. Okay. Similarly, A intersection B whole complement will be equal to A complement union B complement. Okay. You can take examples, and with the help of Venn diagram, you can prove this De Morgan's law. Now, towards the last question, that is the question number 16. Question number 16. What is it? A college awarded 38 medals in football, So we will write here n of f, that is the number of medals in football. How many are these? These are 38. And then number of medals in basketball, n of b equals to 15. Then n of c, number of medals in cricket, is 58. Sorry, 20. If these medals went to a total of 58 men and only 3 men got medals in all three sports, how many received medals in exactly two of the three sports? Okay, so what they are asking, let's just make a Venn diagram. So this is our Venn diagram. This, let's just suppose that basketball, then football, and then cricket. Okay, they have told us that 3 men got all the medals. So here will be 3, and then hmm, the total the total were 58. I will write here M. I'm going to label these areas M. Here will be N, O, P, Q, and R. Now, according to the Venn diagram, what is the total number of persons who got medal in basketball is M plus N plus O plus 3 equals to 15. That is, we got our first equation, that is M plus N plus O equals to 12. M plus N plus O equals to 12. Okay, now see here, uh, total number of men who got N of total medals. Total number of persons who got all the medals is 58. So I can write here one more equation, M plus N plus O plus 3 plus P plus Q plus R will be equal to 58. Okay. We know the value of M and O, M plus N plus O. It is 12 here. And then finding the value of PQR, we will make here equations and then we can solve this question. I hope you understood this question. So that was all about the sample paper of the unit test of class 11, which covers the two chapters, first two chapters, that is the sets and the relational functions.